What if I told you that some of the most advanced AI systems out there are actually being built to think in a way that, well, it mirrors a really unique and powerful style of human focus? Yeah, we're not just talking about machines that can crunch numbers anymore, we're talking about machines that can concentrate. So let's dive into this amazing connection between artificial intelligence and the human mind. You know that feeling, right? You're so deep into something, maybe you're coding or writing or even just playing a video game, that the whole outside world just fades away. People call it being in the zone or having tunnel vision. Well, that exact state of hyper-concentration is the key to understanding everything we're about to get into.
So here's our game plan. We're going to start with that feeling of deep focus. Then we'll jump over to the world of AI and see how these models are learning to handle scarcity and pay really selective attention. After that, we'll introduce a concept called the monotropic mind. And finally, this is the cool part, we'll tie it all together and see why this analogy is such a game changer.
All right, first up, let's really unpack this idea, the power of deep focus. What does it actually mean to be completely, utterly absorbed in something? This isn't just a cool phrase we use. It's a real cognitive state where our brain basically decides to pour almost all of its resources into one single channel. All the other distractions, they just get filtered out. And your performance on that one thing you're focused on, it can go through the roof. It's a fundamental human thing, and, as we're about to find out, it's something AI developers are now desperately trying to copy.
Okay, so how in the world does this link up with AI? Well, it turns out that AI also has to find meaningful signals when it's just surrounded by a sea of noise. And it does this by managing scarcity, using a cool principle called sparsity.
So what is sparsity? Okay, imagine a massive data set. Think about complex brain scans or tons of financial data. Most of that data is actually just, well, empty space or totally irrelevant background noise. The real, meaningful info, the good stuff, is sparse. It only pops up in a few tiny, specific places. Sparsity, then, is the whole idea of teaching the AI to focus only on those important little bits and ignore the rest.
One of the ways AI learns to hunt down that important signal is through something called a diffusion process. So in a nutshell, you take clean data, you flood it with a bunch of random noise, and then you train the model to clean it all up and find the original structure again. To do this, it has to get ridiculously good at telling the difference between the meaningful pattern and all that static. It basically forces the AI to learn what really matters.
But here's the catch. For a long time, older models would accidentally damage the important sparse information while they were trying to clean up the noise. That's where newer models, like something called sparse data diffusion, come in. They're designed specifically to recognize and protect those few crucial bits of signal, which makes them way better at dealing with messy, real-world data.
And that brings us perfectly to our second big AI concept, selective attention. So if sparsity is about realizing that only a few things matter, attention is the tool the AI uses to actively focus on those things.
Think of it like this. You're at a super loud party. You can't possibly listen to every single conversation at once, right? So what do? You tune into one person's voice and you filter out everything else. Sparse linear attention lets an AI do pretty much the exact same thing. It just masks or zeroes out all the irrelevant data so it can pour all its computational power into the features that are actually important for whatever it's trying to do.
And this chart just lays it out so clearly. On the left, you've got the old way, dense attention. That's like trying to listen to everyone at the party at the same time. It's just a total mess, super inefficient, and costs a ton of computer power. But on the right, you've got this new sparse linear approach. It's targeted, it's efficient, and it's so much more powerful precisely because it knows what to ignore.
Okay, we've spent a good bit of time inside the machine. Now, let's pivot back to the mind. We're going to give a proper name to that kind of hyper-concentrated thinking we talked about at the start. It's called the monotopic mind.
Monotropism. It basically describes a tendency for your attention to be pulled, like a magnet, toward a very small number of interests at any given time. It's a cognitive style where the mind just works best, most comfortably, most efficiently, when it's in a deep, single channel of focus. Now, this style is often seen in autistic people, but really, it can describe any of us when we're in that state of hyper-concentration.
And here's the most crucial takeaway. For a monotropic thinker, trying to split their attention across a bunch of different tasks, multitasking, can be incredibly draining. It's just not efficient. It just goes completely against the grain of how their mind is wired. But When they can pour all of their cognitive energy into that one deep channel, wow, their ability to process information and solve problems is just immense.
And this right here is where everything clicks into place. We've talked about AI that finds sparse data. We've talked about AI using selective attention. And we've talked about a human mind that thrives on single-channel focus. Now let's look at the absolutely stunning parallels between them.
And I'm not just talking about a loose metaphor here. The underlying logic, the actual architecture of how these AI systems work is deeply, deeply similar to the way monotropic cognition operates.
I mean, just look at this table. The parallels are they're undeniable. The focus mechanism? For the AI, it's masking irrelevant data. For the mind, it's an intense single-channel focus. It's the same strategy. Both achieve incredible efficiency by just getting rid of distractions. And both of them end up giving you a much clearer, more understandable output, showing you exactly what they were focused on. It's incredible.
So, okay, this is more than just a neat comparison, right? Understanding this analogy has some really profound implications for how we build and how we think about artificial intelligence.
First off, it makes AI way more efficient. By teaching it how to focus, we save a massive amount of computational power. Second, it makes AI easier to understand. We can literally look inside and see what the model thinks is important. Third, and this is maybe the most important part, it gives us a really respectful and authentic way to model a cognitive style that's a key part of human neurodiversity. And finally, it proves that we can learn from the human brain to build better, smarter, more intuitive artificial minds.
This quote from the research paper just nails it. Minimalism in resource allocation, high interpretability, and authentic representation through sparsity. Whether you're talking about a cutting-edge AI or a focused human mind, the core idea is the same. You get these incredible results through minimalism, through clarity, and by having an authentic focus on what really, truly matters.
So, I'll just leave you with this final thought. We're always asking what we can teach our machines. But as we build these AIs that reflect the amazing and diverse ways our own minds work, maybe the bigger question is, what can they, in turn, teach us about the very nature of being human?